today we're going to be developing probability models for an experiment, and we're going to use them to determine the probability of an event. So if you haven't already, pause this video and get your note page all set up, and then we'll get started. All right, let's go ahead and get started. First of all, we need to know what a probability model is. So let's write the definition for that. Okay. Oh, I have my L and T mixed up in my thing. Okay, so probability model. So a probability model is a list of each possible outcome along with its probability. Okay, so it's just a really nice organized way to show the probability for each possible outcome. So let's take a look at an example. So let's say that Molly has 3 pennies, 4 nickels, 3 dimes, and 2 quarters in her pocket. She takes one out. Okay, so what we're going to do is we're going to set up a probability model for this, and we're going to be listing out the probability of her pulling a penny, a nickel, a dime, and a quarter. So this is how it looks, and I'm going to just, you don't need to use a straight edge unless you want to, because you might not have one handy. You can definitely freehand a little table if you want. Using lined paper really helps because then you can use those lines to guide you. This does not need to be perfect. I am just happen to be a bit of a perfectionist. Okay, so we're going to have outcome and probability here. And then I'm going to divide this part into 4 equal spaces. So we have one for penny, nickel, dime, and quarter. Well, kind of equal spaces, not exactly equal, but that's okay. So what we're going to do is we're going to list all the possible outcomes across the top. Okay, so one outcome is that you draw out a penny. One outcome is a nickel. One is a dime, and one is a quarter. So those are the 4 possible outcomes. If we were writing out a sample space for this, then this right here on top would be our sample space. And now we're going to find the probability. Okay. All right, so let's take a look here. For a penny, there are 3 pennies out of, this is 7, 10, 12, out of 12 coins altogether. So the probability for this when we reduce it is going to be 1/4. You can, for the sake of these probability models, I'm going to leave it as a fraction, but you can also write it as a decimal or a percent. Now let's look at nickels. There are 4 nickels out of 12 possible coins that you could have drawn from. So the probability of drawing a nickel when we reduce it is 1/3. So the probability of drawing a penny is 1/4, nickel is 1/3. Now let's take a look at the dimes. The dimes is the same as the pennies because there are 3 dimes out of 12 total coins, which means the probability of pulling a dime out of your pocket is 1/4. Now quarters, there are 2 quarters out of 12 coins total. So the probability of pulling a quarter out of your pocket is going to be 1/6. So this right here is a probability model. Okay. Now I'm going to do one more definition here, and that is uniform and non-uniform probability models. Okay. This is considered a non-uniform probability model because all the probabilities, there's a variation in the probabilities. They're not all equally as likely to occur. So this one right here would be considered a non-uniform probability model. And the definition is all the probabilities in the model are not equal to each other. Okay, so that is a non-uniform probability model. And the way that you can remember this is uniforms. Okay, think about school uniforms. If everybody's wearing a school uniform, everybody looks the same. So a non-uniform probability model is when they don't look the same. So here you have a 1/4, a 1/3, and then a 1/6 over here. Those are different. Those are non-uniform. Okay, so let's look now at another example. So Tristan has 5 different colored cards. So they are red, blue, yellow, green, and purple. So we want to do create the probability model for this. First of all, the sample space is red, blue, yellow, green, and purple. And we're going to assume that he's going to pick a card randomly from his deck of cards. And we're going to find the probability of him drawing each color. So let's just set up our model. Try to break this up into fifths as evenly as I can. Let's see how I do. Oh, not too bad. Let's see. Yeah, that's all right. Okay. So outcomes. Outcomes always goes on the top. The possible outcomes here are red, blue, yellow, green, and purple. So you have red, blue, yellow, green, and purple. Okay, so, and then we have our probability below. So for red, there is 1 red card out of 5 cards total. So the probability is 1/5. For blue, there is 1 blue card out of 5 cards total, 1/5. And I think you can guess the probabilities across the board. Since there's exactly 1 card of each of those colors, the probability is going to be equal. Or, as we can say, uniform. So uniform is when they are all the same, like when somebody wears a uniform for school or for work. It makes everybody look the same. So let's define uniform probability model. Okay, so that is all the probabilities in a model are equal. Okay, so all the probabilities in these models are equal. So let's actually, I'm going to have you guys practice this now. So I'm going to put 2 practice problems on the back side of this sheet. I'm going to have you guys create the probability models and state whether or not it is uniform or non-uniform. Just remember, you can pause at any time during this video. If you didn't catch something and need to go back and write it down, just go for it. Okay, so let's get some practice in. Okay, so here's the first one. Rolling an 8-sided polyhedron with the numbers 1 through 8. Okay, so it's like an 8-sided die. So what I need you to do is I'm going to have you do the create a probability model, like I showed you on the other side. And I'm also going to have you tell me whether it is uniform or non-uniform. Okay, so that's one practice problem. And another practice problem. Choosing a marble from a bag of marbles containing 1 green, 2 red, and 7 blue. Okay, so you're going to create the probability model. And you're going to decide whether or not it's uniform or non-uniform. Okay, you can go ahead and get started on that. You don't need to pause it yet because I have to get all of my tables set up just like you do. So you can be working on your tables while I'm working on my tables, and then we'll talk about, I'll warn you if I'm going to give any answers away here. You are going to have to pay attention to how many outcomes there are so you know how big to make your table. I'm not doing the best job making my table. It's all wonky, but that's okay. It'll work. And your tables certainly do not need to be perfect either. Okay, if you're not finished yet, go ahead and pause it because I don't want to give the answers away. So go ahead and pause. All right, so let's go ahead and take a look at this. The outcomes for this are the numbers 1 through 8. So I'm going to fill in my outcomes here. Oops, 7 first, then 8. They're all equally as likely to occur. This is the same thing as like rolling a die. So that means rolling a 1 is 1 outcome out of 8 total. 2 is 1 outcome out of 8 total, and they all are going to have the same probability. Okay, now we need to decide whether this is uniform or non-uniform. So think about it. Do they all look the same? Yes, they do. So this would be uniform. They are all uniform. They're all the same. Now let's look at the next one. The outcomes are green, red, and blue. So you're going to do green, red, and blue. Okay, so the probability of getting a green, you have 1 possible green marble out of 10 marbles total. So this is going to be 1 out of 10. Then for red, you have 2 marbles out of 10 total. And when we reduce that, we get 1/5. So here's our green probability, our red probability. And now for blue, there are 7 blue marbles out of 10 marbles total. So this probability is 7/10. And looking at these probabilities, are they all the same? No. So this is non-uniform probability. All right, Bobcats, you have an assignment to do that is linked on your slide for today. And please feel free to bounce into the main session and ask me any questions that you have.